Let's continue our discussion about the sense of vision. One of the things that makes vision such a powerful sensor is that it is a long-range sensor. It allows us to sense the world beyond our fingertips. Our fingertips, our arms, only allow us to reach and explore a relatively small part of the space that's around us. Well, sometimes the most important things that we need to know about are far beyond the reach of our fingertips. By the time things are that close, it's perhaps too late. So vision allows us to see for tens of meters, hundreds of meters, a very great distance, and that is a really big virtue of the sense of vision. Another important characteristic of the sense of vision is that it provides a very rich amount of information. We know something about the shape of the object, we know something about the color of the object, and that shape and color, in addition to texture, allows us to classify the object to work out what sort of thing it is. Is it a thing that we're interested in? Is it something we want to run away from or we want to move towards? What sort of object is? And that's absolutely critical for many, many applications for people and also for robots. Another great advantage of vision is it gives us information about motion. And it tells us about how things are moving around us, so we can see an object and we can see it moving. Is it getting closer to us? Is it going further away? But it also provides a lot of information about how we are moving. So as we walk through the world, other things appear to move past us due to our own motion. The fact that so many animals use vision and that the sense of vision has evolved independently multiple times here on planet Earth argue, I think, for the effectiveness of the sense of vision. For almost all animals, we use the sense of vision for the really important things in life. We use it to help us find food, we use it to avoid being eaten by other animals, and we use it to find our mates. So all the important life functions are mediated through the sense of vision. Have a look at these tasks being performed by a variety of different animals. Consider the bee, and a bee is a very small animal with a very small brain, but it's got two eyes, quite complex eyes, very different sorts of eyes to ours, but it can perform quite complicated functions. It can fly for a long distance in order to locate some flowers that other bees have informed it about. It can land on a moving flower. It can tell the difference between a flower and a leaf. So quite complex functions critical to the life of the bee and its colony are performed essentially using vision. In the middle, we have somebody catching a ball, and they're using their eyes to catch the ball. They're not using GPS or any other kind of technological sensor. This person has got their eyes on the ball, and that's a very, very well-known expression, watching the ball as it moves through the air, and they've got some sort of mental model about how balls move through the air, and they're using that then to plan how their hands should move in order to achieve a successful grasp of the ball. So we're using our eyes to sense the ball, we're making a plan, and then we're moving our hands in order to intercept it. And the last example is driving, where we're using our eyes to observe the road, people and cars that are moving on the road. We've got an idea of where it is we want to go, so we're using the visual information with a goal in mind. We're making a plan about how to navigate down this particular bit of road, and then we're acting by turning the steering wheel, pushing the brake pedal, or the accelerator.